For this problem, I want to start by looking at the triangle that I'm outlining in red right now. In this triangle, we see that we have a right angle, which lets us use the corollary to the triangle sum theorem. In particular, I know since the right angle is 90 degrees, then the other two angles, which is the measure of angle 1 plus the 40-degree angle, must sum to be 90 degrees, which means that the measure of angle 1 is 50 degrees. Since the measure of angle 1 is 50 degrees, then its vertical angle must also be 50 degrees. So 3 is also 50 degrees since 1 and 3 are vertical angles, and vertical angles must be congruent. I now want to look at the triangle that I'm outlining in blue. We have another right triangle, meaning that since we have a right angle, that the other two angles, so the measure of angle 3 plus the measure of angle 5, must equal 90 degrees. Also, since the measure of angle 3 is 50 degrees, then the measure of angle 5 must be 40 degrees. Okay, so we have a 50-degree angle here, 50 degrees here, and 40 degrees here. Let's now look at this straight line where we have angles 1 and 2. Because I have a linear pair, I know that the measure of angle 1 plus the measure of angle 2 must be 180 degrees. Since the measure of angle 1 is 50 degrees, then the measure of angle 2 must be 130 degrees. If the measure of angle 2 is 130 degrees, then its vertical angle, which is angle 4, must also be 130 degrees. Lastly, I'm going to look at the triangle that I will highlight in, let's choose this pink color. And of course that makes everything disappear. Okay, in this pink color, I know that the measure of angle 4 plus the measure of angle 6 plus 20 degrees must equal 180 degrees. So since the measure of angle 4 is 130 degrees, I know that plus the measure of angle 6 plus 20 degrees equals 180 degrees. The measure of angle 6 plus 150 degrees equals 180 degrees. So the measure of angle 6 is 30 degrees. And that solves for all 6 of my missing angles.